A warm welcome to everybody who is listening to us on LC Live. We welcome you to this program. Today it's going to be about science and how stories can aid the science classrooms. We have with us Vinay Suram. Vinay Suram completed his master's from IIT Roorkee in 2013 and joined the Azim Premji Foundation. He has been working with the government school teachers to make science learning more experiential for students. This has included developing modules around concepts in science and orienting teachers to teach those concepts and take them to their classrooms. His academic interests includes history, philosophy of science, neuroscience, and science education. Welcome to you, Vinay. So glad and so grateful that you could spare the time to be with us because everybody is very interested, particularly in science. Today is the day of science. Times are, a STEM is a very, very important concept. So, and this thing has to be developed from the very earliest stages. So, we're talking about primary school children here. Before we ask you any general questions, we would like to begin, Vinay, with something specific to your article. You've said, I'm quoting from your article, science is a way to develop the world by exploring and drawing relationships between the different elements involved. A very complex statement, for those who don't know science, and it's also complex for those who want to teach science in class to make sure what these things mean. So we'd like you to elaborate first on A, exploring and drawing relationships, and B, different elements. These are the two concepts which I think are very, very important in this particular statement.
Yeah. At the outset, thank you, Prema, for having me here and giving me an opportunity to share my views. That is interesting. If we were to see about science or the way it has been mentioned in the article, I guess usually we hear some two to three different views when we speak of science. The dominant one that most often we hear, a view that dominates is science as factual knowledge. Science is a collection of facts, but the other thing is also that science is also a process to understand the world around. So when I mentioned the statement that there are different elements involved and you are trying to draw relationships between them, so what I mean is, let's start with what I meant when I said elements. See, there are certain objects in and around us. Those objects that we see and we can touch, water bottles, bags, pens, books, and all these sorts of things. And there are certain things that we necessarily not see or touch, but we feel. We feel hot, we feel cold, we feel breeze, we feel windy. And there's certain interesting phenomena that we observe around. We see rainfall, we see dews at noon, the leaves very early in the morning. For the sake of argument, we see sun rising and sun setting, at least in a general sense. So we see all of these things around us. And interestingly, when we try to interact with these objects in and around us, we have such an amusing experiences. Let me take these examples of, for example, sound. This is something which we might have done, every one of us might have done. You fill a glass with water and you hit it with a spoon. You hear certain sound and you slowly vary the level of the water and you see the sound changing. You feel there's a change in the sound. And an empty glass might make, it's a different sound altogether when you compare it to the one with the water is filled. I guess that's where this phrase comes from, empty vessels make more noise on a one thing. So all these sorts of experiences, we have it in our day-to-day lives. And these are quite amusing. A rubber band, if you stretch a rubber band and pluck it, you will hear some sorts of sound. And when you try to drop certain objects, I guess you would be very careful while dealing with materials made of glass than with any other materials made of steel or something. You know that certain objects break when they fall. And there's also certain things that we get to see certain fruits are available only in some seasons. We get plenty of vegetables in some seasons, sometimes they're completely opposite. So, for example, mangoes we get usually during summer, some sort of mangoes, like Banganpalli, of such sort. So all these sorts of things happen around us. And when we try to interact with these things, we tend to identify some patterns, either knowingly or unknowingly. No, it happens throughout for everyone, I guess, even from kids to adults. I guess we have this sense of exploration and seeking patterns hardwired into our brains. We tend to be more explorative in nature, I guess, by our own nature itself. So when I was mentioning about science, so I was trying to get this particular way of science into forefront, rather than seeing it as a collection of facts, like Earth revolves around the sun or Earth rotates around its own axis, rather than looking at it in terms of this own collection of statements, gravity acts on every object. It would be much more helpful to look at science as something which is trying to arrive at this understanding. I mean, you are trying to put some efforts into asking questions like, why is this thing happening? Uh, what are the commonalities between some of these common occurrences that I see? I mean, the same example of a glass. So, why does the sound change when I vary the water level? So, all these sorts of questions. And the other aspect is also it's very important that the scientific knowledge, what we call, is susceptible to change as well. As in, the more and more amount of information that comes, the way you understand the world will also change. I mean, just to quote a very popular example that most of us use, I mean, earlier when we were studying, we used to read a solar system as 9 planets. And I mean, this is a very common example, but it's being cited very often these days. Nowadays, we don't treat Pluto in the same sense as that of a planet. It's because there have been certain observations that have recently come up, which the international society had to take a call whether to treat it as a planet. I was trying to put forward this view of science where this is a process to understand, this is a mechanism to understand the world around us. And those elements that I mean are those things that are in and around us that we feel, that we see and touch, and certain concepts which might not be straight away experiential, but those are the concepts that we use to explain the phenomena happening around us. For example, the whole crux of the article, right, density. Yeah.
That's very interesting, Vinay. How and so that leads on to our next question, which is also partly a statement that you made in your article. How can a teacher pave the way for students to, and this is the quotation, practice the value of exploration, recording, and analyzing as a methodology related specifically to science? Here are three very, very important words, Vinay: recording, analyzing, and exploration.
Explore.
So we'd like to just ask you how these three things are related, how a science teacher can go from one to the other, because it's a logical kind of chain.
Yeah. I guess, I mean, as I was mentioning earlier, so these sense of exploration and analysis is somewhere every one of us does at some extent or the other. We might do it knowingly, we might do it unknowingly. And it happens to students or children, adults of different age groups. So we must have noticed this month-old babies, uh, a baby with 3 months, 4 months, 5 months of these sorts. They try to make a sense of the world by touching things around us, trying to put it in their mouth, I don't know, to taste it or bite it. And sometimes they also drop each and everything they get their hands on. They drop it and see some. Usually, what happens if you seat the kid on a higher space and you give him a spoon, the child drops the spoon and it makes an interesting sound. And you might notice the kid laughing. and mom or dad, whoever is around, picks up that spoon and gives it back to the child. The child drops it again. So there is some sort of an exploration that is happening even at the very, you know, from the very beginning. So I guess the better place to start would be, utilizing this innate ability and allowing the children to explore things freely, and then share what their experiences are and what their observations. I'll share something which is very personal to me. As in, I have a 4-year-old daughter. She plays with water a lot. I mean, uh, usually the house gets very messy when by the end of the day. Her favorite pastime is actually emptying those paint bottles into water. Those watercolor, she puts it in the water and then dissolves into those things. The water gets colored. I was curious. I mean, I was observing her and I got curious. I mean, rather I should be using the word furious because she is wasting so many and so many uh, colors, bottles of colors. But I asked her, "What is it that you are trying to do? Why are dissolving all the colors into water? The water is getting changed." She said that she is trying to make new colors. I got a bit curious. I asked her, "So, I mean, what do you mean by new colors?" She then showed me, "See, I have put red color in the water now. I'm going to put yellow color now. I'm going to mix yellow color. You will get orange." Oh, that is interesting. She was trying to do that and repeat it. And she was also saying, "See, now I mix blue and red colors, you will get purple." I guess everybody has many examples of these sorts. Uh, so, I mean, what is it I'm trying to say? I'm trying to say that this is a sense of exploration that every kid innately has. And also, there are certain things that we observe as well, we experience as well. For example, it is very difficult to walk on sand in comparison to walking on a concrete floor or a stone floor. And also, usually you see signs in the malls or in some places where a caution is meant wet floor. If you ignore the sign, there are high chances of you slipping and tripping over. The similar experience happen even when oil is spilled on a floor or you step on a banana peel. So one might actually look at these things happening across and ask, is there any commonality that is causing these things? I mean, everybody is tipping off in all these cases. So is there any common thread that is trying to connect these three different cases, which might seem completely disconnected, different happening in different contexts? I guess so. This kind of exploration and engagement is would help the children to understand. I mean, not to understand, as in to engage with what is happening and how things work. So, when a teacher tries to do it in a classroom, I guess it would be much better to start with those experiences that the child is quite familiar with. Ask them what they observed or what they have experienced while doing some task. Sometimes it might happen that the teacher may have to slightly push the kids to look at some specific things which the curriculum expects the child to learn. But it is fine. But the best place would be to start with this free exploration and then allowing the kid to share the observations and experiences with a constant dialogue and conversation between the teacher and the student.
Yes, this constant dialogue and discussion with the students is very important, and it's so much better for a child to have the confidence to ask questions rather than be told it's in the textbook, you better just learn it, you know. So that's very important indeed. As an extension of the above, what we just spoke about, what value has these three words? What value have they to learning in general, not just science, but all the subjects? How can a teacher extend this for, let's say, geography or social sciences or EVS? How can teachers ensure that students understand and use these processes, not just for science, but for all subjects?
No, I guess this ability to observe and analyze is crucial for learning in every subject. I mean, maybe if we provide the students with enough experiences and ask them to identify recurring patterns, it could, I mean, this sort of exercise and activity could be done in any other subject as well. So, as we were discussing, so this is basically about how the teacher tries to get things like, what do you think we should do now, or how should we proceed from here? During the conversation, these are the kind of questions that the teacher could ask, or how do we know what is happening? And probably while mentioning these things, the teacher might have to support the students with some sort of information as minimal as possible, so that the this explorative nature is not curbed, but the student feels that I mean, he or she is not lost. I mean, for example, I was just trying to see, I mean, I'm sure this is a very good example, but maybe the primary grades, if we take an example of English per se, uh, there are certain statements like he was walking to the park, she was walking to the park, they were walking to the park. So imagine that we have these statements of some 10 to 15 shared with the student. And maybe the student looking at those statements, going through the statements, might come up by saying that whenever we use the word they, the follow, I mean, it's were is something which is following, and whenever it was a singular person, he or she, was actually verb is something that is being used. So this is what I was trying to. I mean, this is what I feel that this nature of exploration and trying to analyze things would have in common for all the other subjects as well. Even if we look at social science, for example, there are certain things that you observe. For example, seasons. You might observe that the temperatures usually during certain months is very high, and it's not very high in the other months. In certain months, you see there is a large amount of rain, and in some months you don't see it. So this basic idea of the seasons itself can be very observed by connecting to the experience of the child. I think all these sorts of things are somehow connected to this idea of exploration and analysis.
Yes. So, curiosity that children automatically have has got to be harnessed to include what we call, in a very limited kind of way, subjects, but actually we know is knowledge in general. So that the curious element that is there, why, how, these questions are to be encouraged. There have been so many very interesting statements in your article that we I felt that there are certain things that automatically are very complex, and so I've chosen another. Here's a very interesting statement from your article. The language that stories use is often connected to the students more than scientific vocabulary is there a specific way of writing a genre, for instance, that encourages the language of science? How would you define it? What are its characteristics and how can it be developed? So, there is a language of science which is exact, which is very, which sticks to the facts, but it's still got to be made interesting for students. So, I'd like you to comment about that language of science.
Yeah, so that is very interesting. I mean, put it in the combination of words, language of science. I guess we need to look at it from different perspectives. Let me try to share my thoughts on what I feel we see. Uh, I mean, when I hear this word language of science, I mean, typically, if we were to look at the way that the language stories use, or any sort of written text use, the basic thing could be for whom we are writing it and what is being expected out of it. These two questions actually guide the whole story or the written format, whatever it is, the text. So one might actually adopt a creative writing approach, wherein one could use all the imagination that could be mustered and bring a narrative. The other way could be a rational writing approach where we're trying to bring in the facts on what is happening. And this is typically what we see in report writing, right? So this is what happened and this is what it meant. These many. People have said so and so, all these sorts. So, but what does it matter when it comes to the language of science? For example, when it comes to science, an important thing is that it has a terminology. When it uses certain words, it has certain vocabulary which carry a specific meaning in context. For example, when we say force, there's a separate specific definition to force, and associated with it, force are certain characteristics. For example, when we say a force is acting on an object, it also means that the object will be accelerating. So this is something which comes along with the usage of the word force. When we say accelerator, it could mean that there's a change in the velocity, either it could be direction or the magnitude, all these sorts. I mean, so what I'm trying to say is when we use a word in science, there are certain associated phenomena that are taken to be granted. So this is what the whole thing is happening here. The statement, a force is acting on an object, means all these sorts of things happening. And we have all these words called energy, power. So whenever these words are used, they bring the associated characteristics too. See, but here comes the interesting thing. These words are not limited to science alone. I mean, it's not limited to textbook alone. For example, you use the word force colloquially, use the word energy, too. You use the word power too. I mean, let's try to recall certain phrases where we hear all these things. Let's say we hear something called the police force has stepped in. It's still the same force. I mean, speaking in terms of English spelling. But what does the police force here mean? Or we hear something of this sort. Why are you pressurizing them to do things? Or this typical Star Wars. May the force be with you. So we hear all these sorts of things being used, and similarly, when we say energy or power, he has so much power. He has so much potential. He is very energetic. See, all these phrases the child listens to even before stepping into the classroom and formally exposed to these words in a science textbook. And now, what happens is the context in which these words are used in the society outside the world, outside the school, and the way these words are used in a textbook when it comes to science might be slightly clashing, as in there could be differences of understanding between these two contexts. Now, this causes certain confusions for the child. The second thing that I see is, it's a higher tendency to with the language of science, the vocabulary that is used, there's a high tendency that it alienates certain sections of students. No, it seems to, for the lack of better word, elitist, and something that's very not reachable. So I guess if we were to write something in science, I mean, for science, I guess it would be much more interesting to look at the characteristics and then introduce the vocabulary. As in, this is how certain object was moving, or this is how the tortoise was running. And at the end of this whole story, or after later parts of the story, you use the typical terminology that you use in science. I remember an interesting example. Everyone must have heard of Isaac Asimov. So this is an interesting book written by Isaac Asimov, titled "How We Found About Vitamins." So in one of the pages of the book, Isaac Asimov describes the discovery of this idea of vitamin C. The way he starts is quite interesting. He starts by taking the example of Columbus. He says that after Columbus' long voyage, a similar sort of voyage started across Europe, and so when these long voyages happen, the sailors stay on seas for longer durations of time. You need to take care of food. So the kind of food that you would like to carry is one that would be preserved for longer durations of time. So then he goes on stating that what was the experience of sailors on seas? The kind of food, what is the effect it is having on the sailors' health? So he goes on saying that sailors were suffering bleeding gums, etc., etc. So he was actually trying. He was stating the conditions of scurvy without explicitly using the word scurvy. And then, after describing these conditions in the context of sailing, he then goes on to a similar phenomena was observed in prisons where there is no change in the menu of the food, or hospitals where a similar sort of menu is served. Even this similar symptoms were observed. And then he goes on to saying what could be done. I mean, what could be the solution for this thing, and uh, how did someone address this problem? Then he narrates an interesting experience. He observes that even army suffers the similar symptoms, but even in the army, it is the lower ranks that suffer from these symptoms, and not the higher ones. I mean, it was the common soldiers who usually suffered scurvy, and not the officers. He goes on saying that one reason was officers, along with bread and barley, they also have access to fresh fruits and vegetables, which the common soldiers do not have access to. And I mean, this is how the story goes on. I think the beauty is there's a context there. He is trying to build a narrative around an experience, a common phenomenon that is happening across different groups. I mean, different contexts. You have a sailing context. You have someone in prison. You have someone in a hospital, and you have someone in the army. There is some sort of a common thing that is happening, and someone is trying to address things. So I guess when we speak of language, also, this is the kind of thing that we should keep in mind, as in not to alienate sections of students by bombarding with vocabulary, and also making sure that the vocabulary is vocabulary should not be the center stage, as in the characteristics of each of these terms. Understanding those terms should be the essence. Yeah. That's what I feel.
That's very, very interesting. Um, Particularly the fact that children should not, be bombarded with very complicated words, yet understand exactly what the terms of science are and how they are used. Let us circle back to the specific story that you have given in the uh, article that you wrote, The Crow and the Water Pot, or The Thirsty Crow, as it's sometimes called, which we are all very familiar with. We've read it so many times, we've read it to other children also. How about the two relevant points? There are two relevant points there. The crow using stones, for instance, and not sticks, and why the water level rose. These points are connected. But how can a teacher bring about an understanding of a scientific fact that heavier objects will sink and cause a liquid to rise? How can a teacher make that clear? Or related things like that.
Yeah. I think that's where the whole crux of the job of a teacher lies, I guess. So you have a familiar story, you have the context, and you have certain experience that the student has, and now you want to make the child understand what's the scientific principles behind it. I guess these smaller things, for example, the crow was using stones, and it was not using sticks. What could that be? What could be the reason for that? I guess this is a very interesting starting point to look at things. Uh, and especially the advantage with these sorts of concepts, which are quite, you know, which are quite common, as in the floating and sinking of objects is something which everybody experiences. It's a very common thing that we look at in our houses as well. You know that if you take a steel glass and fill it with water, it's obviously going to drown in this bucket. You take a plastic and it's afloat. So I guess uh, considering or bringing these experience of students to the discussion forms the key step in this whole process. I mean, because there are certain experiences anyway which the student is quite familiar with. The teacher has to draw those experiences, engage the student in analyzing those experiences, and then direct the students to think and arrive at what the scientific understanding that is to be built. Uh, I mean, so I'm not sure if this image is visible. Forget about the text that's written here. So, when we were trying to do this similar exercise with certain groups, what we asked them was we just wanted to know uh, what the story is, so that we were going to explore the story. We asked them what exactly do we mean by float and what exactly do we mean by sink. So, I have a tumbler of water here. I mean, I'm just trying to replicate the responses that we got. We, as in the team who has worked. So, majority of the students, majority of the participants' responses was for a floating object. It was this. It was something that is like if this is the level of the water. Prima, is it visible, or should I make it a bit? So, if this is the level of the water, majority of the responses were like this. I mean, they were placing the floating object on the top layer of water. So, and then we asked them, what is it? What do you mean by objects that are sunk? Then we went to the bottom and placed it here. So this is floating and this is sinking. Then we try to provide them with a different sets of images and ask them, is there any other criteria apart from these two things? For example, what if an object is like something here in between the top layer, the bottom layer? What do you call it? So that's something which, uh, if you have never thought about, so they were unable to figure out that where to put this particular object in either float or sink. So the thing is that you this sorts of these kind of examples actually make the students to think through their ideas what they had earlier. For example, whenever we ask the students about floating and sinking, like what kind of objects do float and what kind of objects do sink, majority of them state this thing that heavier objects sink and lighter objects float. Okay, so then the question could be: is this the same thing across? So, would it mean that a 10-gram iron ball would sink and a a 10-gram iron ball would float in comparison to a 10 kg wood or a wooden log? So asking these kinds of questions, I mean, as in you have the student already has a conception as a theory that the student feels it works, and you are trying to provide the student with some concrete examples. So I think providing these sorts of examples would actually make the child to engage in the process more and more. You're questioning the established notions and established notions that have been established in their students' minds. There's also something else. One thing is typically when we speak of floating and sinking, we usually speak of water as the liquid. There was an interesting thing that happened with me. I mean, when we were looking at it, I for a second have never realized that there's a liquid in which the plastic straw in through which we drink juice and all, those plastic straw pieces would actually sink. I mean, that was something quite interesting for me when I looked at it for the first time. So we were trying to do this experiment. We were trying to see how could we actually make it more engaging, because those lighter objects sink and sorry, lighter objects float, heavier objects sink. This is one thing which we have. The second thing is there's another established notion that large objects sink and smaller objects float. And the third thing is, does it happen in water alone, or is there anything similarity with respect with other liquids as well? So that's where we observed that when we had a straw base and we had different liquids. One was water, there was another salt solution, and we had kerosene as well, kerosene or petrol. So we placed those straw pieces in all these tumblers: normal water, salt water, and kerosene or petrols. In petrol, the straw piece actually sank, and that was an interesting because that's where it struck to us. that no, this is the best example to introduce the idea of relative density. Rather than saying it's right away, it is happening because of so and so and so. This is something which is quite, visible, and the material is quite available. So, I guess one thing would be to start with the experiences, understand why the student believes so, or what is the student's theory uh, in sticking to that view. Provide the conflicting examples, I mean, challenging examples, and then see how the change could occur. And this is where I think it's the last step, look, exploring the conflicting examples, analyzing the conflicting examples, and then arriving at the desired conclusions. The last step is where the teacher's support is very heavily required. And then there's a high chance the student might feel lost or might feel disinterested because the established notion is being challenged. At one end, it's interesting, and at the other end, it could also be disheartening. The teacher will have to thread this very carefully and balanced in a balanced approach. So what we did was we gave all these sorts of objects to them. So to address this idea of heavier and lighter, larger and smaller. For larger and smaller, it's an interesting thing. So have larger and smaller. So what we did was we took the small cycle ball bearings, those small balls that we see, and then large wooden pieces. And we asked the students to see if this is very small in size and this is very large in size. Now, as per your idea, what should float and what should sink? And when they state it and then they do the experiment, they realize that there's a change in the way that they have thought. The other thing was you have the size is very similar, but the mass is varying, the heaviness is varying. You could take small containers of same size and fill sand in it, or you could use soaps. You cut the soap into different blocks, punch in iron nails into it. Maybe one piece of soap would have 4 to 5 iron nails. The other piece could have 2 iron nails, and there could be another one with no iron nail at all. You are actually changing the mass of it. So, using these sorts of challenging and conflicting examples, and again allowing them to explore and observe and repeat the experiment and analyze. And again, by having the conversation and dialogue, the teacher can slowly bring them to the desired scientific understanding.
One question which leads out of this, but slight digression, and that is how, for instance, do you explain to a third standard child why a ship doesn't sink? It's a huge thing. It's floating on water, and how to associate it with Archimedes' principle, for instance. How do you? So the child says, "How come a ship doesn't sink, but the stone is sinking, or something is sinking?" Uh, I'd really like to know that, and I think a lot of science teachers would also like to know how to explain that.
So that's quite interesting. I mean, just things at such a large scale, and a small iron ball and iron nail sinks, but such a huge and large ship that still afloat and gets all those goods from different countries across the seas. What we tried to do was what we tried earlier was, this clay putty, right? Those blocks of the children play, clay putty. So we gave it to the students and asked them, you just drop it in the water and see whether it floats or not. So they dropped it and they observed it sank. Those clay putty sank straight to the ground. And then we asked them, now imagine the shape of a ship and try to see if you could make this particular putty, clay putty, whatever you have, float. You do whatever you want. Yeah, I mean, I guess, for a grade 3 child, it would be a bit difficult to understand this idea of relative density. But again, if at least even though it's a partial understanding, if the student is able to get to this place that I'm trying to change certain properties of this particular substance, which is making it afloat. So this is quite evident. I mean, the task was the game that we conducted in the class was we distributed the kids into groups and we gave them each a block of clay pudding and asked them. We have certain coins with us. I mean, we had washers, iron washers, and a few coins. So we will award a prize to that particular ship, which can hold large amount of these coins or washers. You use this clay putty in front of you. Other people were trying to get it into the shape of a plate, into the shape of a ball, shape of a shape, and all those things. They were trying to see. They might not have actually understood the idea of trade density at this age group, especially in grade three that you were mentioning. But at least if they realize this aspect that there's certain properties of these objects which when I try to change, this flotation property changes. I mean, this is a perfectly worked out experience, and that's why I can share it with such a confidence. So, if not Archimedes principle, if not the idea of relative density, at least these things comes. You change the properties, and you can see the flotation properties change.
Right. Um, See, there are some observations as a result of the story that you've used. Actually, I counted six. I just very quickly tell you
Yeah.
quantity of water, then uh, the size of the pebbles, then the irregular shapes causing gaps and therefore the liquid not rising, then the uniformity of shapes leading to uniform rise of water. As a teacher, how do you come to this the scientific principles behind the story rather than the story itself? It can just be a story. The cocaine tried to drink water, couldn't do it, and flew off, and that's that. But you're using this to teach something. I really like to know how you come to that point because this is what I think in a classroom a teacher would like to hear.
Yeah, that's very interesting. I mean, the story is quite so simple, and the crow is trying to do something, and all of a sudden we use that to explain different concepts in the classroom. And so, I mean, similar exercise when we first introduced it with. I will share your experience with adults. That's actually quite interesting, and then I'll go to the students. Right? So when we were working with a group of adults, so we asked them, "You must have heard the story of thirsty crow. Could you recite it for us?" So some of them said that there was water in it, and some of them there was little amount of water in it. That's okay, that's quite interesting. Some says amount of water, and some says little amount of water. Could you draw me a picture of that amount of water you think is in the pot? So someone then they try to draw. Some of them have drawn a very little amount of water at the bottom of the pot, and some were quite luxurious, so they almost filled it to the brim, and some had half-filled pots as well. So then we asked them, so it's good that you all have different ideas of amount of water. Now, why don't you try to do what the crow has done? Can you actually see? Can you actually see whether the water level rises to the brim? Let's start with small amount of water and see if there is any limit on the minimum amount of water required. And we ask those adults to go out and fetch the stones that you want to put it. So since it's adults, I guess probably, but I mean, they wanted to have some fun. They brought huge stones, and some have brought small pebbles as well. And this was quite interesting because in one of the classes there was very small amount of water, and the participants dropped a huge stone into that glass. So I mean, you could still see the stone on the in the glass, and the water level is still there. I mean, it has risen up, but the water is still there. And then they said that I guess I would like to change the version of the story. It's not very small amount of water. There should be a much more amount of water. So I mean, these sorts of things happen. I mean, they try to see. I mean, no one would have earlier thought about the amount of water as well, right? But once you start experimenting with it, and once you start replicating what is done, they might actually look at what are the other factors that could be involved. So then they change the size of the. So the students did the same thing. The students they tried to decrease the size of the stones to small pebbles, even smaller ones, and even very small gravel. And so those factors that have been listed in the article, surprisingly, many of them the students have stated it straight away at the very first guess. I mean, it's like, sir, I guess the water level, I mean, the water is still stuck between the gaps of the stones. We need to have even smaller pebbles. I mean, once that particular experience is set, I guess the student would, they would actually go on looking at things. I mean, the initial step was to see, to get them onto the job. All the modifications and later modifications, whatever has been done, they did by themselves. I guess allowing them is what, is allowing them to modify, allowing them to come up with their own ideas and try it out is something which is very crucial. Of course, it should not go out of the context, but these sorts of modifications actually help them. And then
Yes.
we try to arrive at this point slowly. I
Hmm.
mean, why would the water level rise?
Hmm.
The interesting point is, I mean, everybody must have played musical chairs.
Right.
Then, game of musical chess, third person comes out who doesn't have a place to sit. And as
Hmm.
in, you have a chair only, then you can sit. If you don't have a
Right.
space to occupy, you can't sit. I guess this is what we try to connect. I mean, water level rises when certain objects are dropped into it because this particular object is trying to occupy certain space, and now since the space has been occupied, the same amount of space has to, the water has to occupy the same amount of space. The best thing is since that's why the level of water rises up. You
Right.
take a lot of water, even it would rise.
Right. Right. It's all very, when you explain it like this, it all sounds very easy. But actually, most of us have been through primary school asking these very questions and not really getting the right answers till much later, maybe in class 8 or 9, suddenly it dawns on you that, oh, this is why it happens. So it's very good that we are training our children from such a young age. Now, here's a question that I think a lot of people would like to ask. Please tell us how you choose a story. Do you allow or make some changes, or what do you do? For example, how useful is the story of the hare and the tortoise in teaching the concept of velocity or speed?
Yeah. So, I mean, I was trying to recall one of the recent updated versions of these stories when you asked me the earlier question. I mean, some of the students have actually said, sir, now the crow is not dropping stones to drink water. It's getting a straw and it's sucking out of the bottle. So that's the most recent updated version of the story that we see across. Yeah, I mean, apart from those things, I guess, see, the teacher could make whatever modifications to the story she wants to do in a classroom. That's absolutely fine. But what should be the things that we should focus on? One thing is, see, these kinds of stories, such as Hare and Tortoise, Thirsty Crow, these are very popular stories. As in, everybody in the class might have heard of those stories. So it's very essential to understand that everyone in the class is of the same page. I mean, whatever the story that we are trying to explore, whatever the story we are trying to represent, that everybody understands it in a similar manner. As in, it should not be that someone feels that this crow is drinking out of a straw, or someone feels that this crow is dropping stones into it. So, the question to answer the question that you asked, I think this is the crucial element. If each and every one child of the classroom is with the same story, same version of the story, it would be much better for the teacher to continue with that particular version of the story. Or else, what the teacher should do is to make sure that this is the story that we are going to explore and this is the version that we are trying to do,
Hmm.
which might slightly, you know, influence the students' participation if it is a very popular story. The
Right.
other thing is, yeah, yeah, go
Please go
on.
ahead. Yeah, sorry, go ahead.
So the hare and tortoise, the thing about you asked about the speed and velocity. See, the hare and tortoise story has different versions as well, as a very
Right.
minute things, which are very essential for the classroom. As in, everybody knows that tortoise wins the race,
Right.
but uh, some of the students said that the rabbit also arrives at the end line, and some of them didn't even worry about the rabbit part arriving at the end line. No, that becomes very essential when you are trying to represent it. I mean, the article says to represent it on a graph. So that's very essential to sort of clarify the kind of version that we are sticking to. When you plot that graph, it becomes very beautiful. You will understand. Uh, Typically, rabbit runs faster than tortoise. Everybody knows,
Right.
but tortoise
Right.
wins the race. Does it mean that the rabbits are slow? Does it mean that tortoise are very fast? So what is happening over here? I mean, you are looking at this particular experience, the presentation of a graph, and you can ask these questions. Since the rabbit has slept, had the rabbit not slept? Or do you think the rabbit was running faster than tortoise? Or do you think the tortoise was running faster than the rabbit? So when you use these kinds of, I mean, the idea is to use these smaller things which usually we miss in a story, which becomes very essential for us to teach the concept that we intend to. Asking these kinds of questions and conversation is essential. That's where the liberty of a teacher is. The idea is to stick to the version that's more that everybody approves of.
Right.
And you can
Right.
change whatever you want.
You may, but do you have any particular, for instance, do you hold workshops where teachers create their own stories to use in science classes, illustrating scientific facts? Do you have anything like that for teachers?
I'm trying to recall if there's anything. Uh, yeah, I remember one of the workshops where the teachers were trying to understand plants, characteristics of plants in different conditions. So one of the teachers had actually written a story about a kid who sleeps. I mean, who comes from school reading about plants and everything, and he goes to sleep. And in the dream, he goes to different lands. He goes to an aquatic environment where he sees certain plants, certain features, and then suddenly he is zoomed to a place of a desert as a whole sand, and there are certain other kinds of plants that the kid sees. And suddenly it comes to another place where there's a huge amount of rainfall, the kind of trees that the kid sees there. So there was this. This is an interesting thing that teacher has tried to develop her own. So I guess this is a huge opportunity for the teachers to knit these smaller experiences into a sort of a narrative story. This is one thing that I could immediately recall.
Right, right. Now, there's a question basic here, which I think of, we've all wondered. What is the importance of learning science in school, Vinay? Do you think it impacts logical thinking and minimizes things like superstition or blind belief? Do you think science has a part to play in that particular thing?
Yeah, well, that's very essential since we make the students read science as a compulsory subject till grade 10. But of course, I mean, the sort of things that we are expecting is common across all the other curricular areas as well. I think that we spoke about analysis, exploration, and all. But coming to specifically to science, uh, I guess it is very essential. So, this particular notion of science as a mechanism to understand and view things rather
Yes.
than viewing it as a collection of facts. So, this particular view would always help. So, this view actually makes the student to question and explore things. So, I mean, I recall something that I have read in one of the books. It might sound a bit different, but I was just saying, let's say that a person is ill, he's suffering from something, and if the premise is that he must have committed some sort of, he must have troubled someone else, and
Yes,
that's why
yes,
this person is suffering from ill.
yes,
If
exactly.
this is the premise, the solution that you would try to look out is to minimize the effect of this trouble. I mean, since you have troubled someone else who are ill, either you should make sure that you do something else to pacify this thing, or you just wait for the days to end. But
Yes, yes,
what if the view is this? Uh, this particular illness might be caused by some sort of water effect. I mean, the food you take and the kind of drink that you might actually
yes,
get.
yes,
And now, see, the premise is this: the way you approach the problem would be completely different. You would look
yes,
at
exactly.
that particular person has been the kind of things that he has ate, drank, or something of that sort. I guess this particular view, I mean, what science does is to look at things in this particular manner. You look for what's the premise which it is coming from. You try to explore the reasons and try to come up with a solution. But again, one should remember that every person belongs to a social world as well, which
Of
has
course,
certain
of course.
constraints as well. You should be able to negotiate with those constraints.
Yes. So that's very important, particularly, in a country like ours where there are so many different beliefs. And I think science has a very, very important part to play in explaining phenomena, no matter what people's personal beliefs are. That's what I think.
Yeah,
So,
just one
please, please
Yes,
go
no.
ahead.
So the other important feature, I mean, another important nature of this particular scientific knowledge is it is continuously evolving. I think that is actually an essential thing that that the student should actually understand. What you say today, I mean, it does not change overnight, but it is susceptible to change provided you have some information which might contradict the current understanding. But there's always a scope for this to change. I think this evolutionary nature of scientific knowledge, this dynamic nature, is something which the student should understand.
Absolutely. So we come to the last question, Vinay. How do narratives of day-to-day experiences aid the scientific temper? Let's say I'm walking along to school and I notice certain things along the way, especially I'm talking of botany, trees and flowers and the general atmosphere or the general environment around us. How do these day-to-day experiences, aid us in the scientific temper, or learning science, how leaves change color, how the rain affects? That is something I'm sure everybody would like to hear about.
Yeah. The interesting thing is the scope that we have in a classroom to connect what we learn in a formal sense to all these spaces around the outside the school or a classroom. I guess unless we make the connection, uh, it would be very difficult for. I mean, they would retain it as two different. It is one a world happening outside the school and a world which is situated within the curricular areas of the school. So trying to bridge these two things is the essence of, I guess, one of the key elements of science teaching. And only then I guess it would aid in scientific temper. Because this is what we have been speaking about, right? All through the examples that we have been discussing in the floating, sinking, or air and tortoise, all these sorts, these experiences are not something which happen in a classroom. These are something which the student experiences outside the classroom. The thing that you are trying to do is you are trying to get those experiences and look at it in a formal manner in a school. You're trying to teach this is what we call it as density, this is what we call it as size, this is what as volume. So the important aspect is to connect these experiences outside the school to the classroom, to the curricular areas. This is this is an important point in it. Unless we do it, unless this connection is explicitly made, there's a very high chance that the student still retains, sees it as two different ideas. So that's what we were saying when we spoke about the language of science, forces. I would just share an example. I mean, forgot to add it there. It is something called free fall in science. When we say free fall, it is that the objects are experiencing only one force called force of gravity. But look at the word free fall. Fall typically means falling down. See, unless the classroom connects that free fall when we mean it's not just falling down, it is in this sense that it tries to see. I mean, unless and until this connection is explicitly made, the student might answer what a free fall is correctly in the examination. But if you ask him to give an example, him or her give an example, he might actually be giving those examples of objects falling down rather than objects going upwards as well. So I guess there should be a connection made in the curriculum. At least should promote the students to observe in and around. Maybe the teacher might not be aware of all the things happening, coming from two different contexts, the student and teacher context. But if the classroom's environment in such a way that it encourages the students to observe what is happening outside the classroom as well, to look at things, I guess it helps. It definitely aids in building the scientific temper.
Well, unfortunately, our time is up, and we have to stop this very interesting discussion. But before we really say bye just now, I would like to know what exactly, just in a few words, the philosophy of science is, because your CV says you're interested in the philosophy of science. What exactly is meant by that?
This is an out of syllabus question.
Yeah, it is.
I mean, that's what I'm trying to explore. I'm trying to understand what this philosophy of science is. But what I feel is, these different views that people hold of, I mean, as a factual body of knowledge, as something which is dynamic in nature, as a mechanism to understand things and explore things. So, looking at this nature of science, this holds, I mean, this actually influences the way science is taught in classroom as well. I mean, if a certain person holds that science is a collection of facts, the way it is dealt in a classroom would be completely different. If it's seen as a mechanism of understanding viewing things, the way the classroom happens and the way the person reciprocates these scientific ideas would be completely different. Because when I'm trying to understand this philosophy of science, I'm trying to see what are its implications in the classroom, the different notions of science and how it impacts in a classroom. And the other thing is that, see, there are certain interesting things that happen. It's an evolutionary in nature. What we might feel true today might be something which changes over the next few days or few centuries. Not few days, few centuries. The best thing that I could see is that we know the description of motion of objects. As in, we feel that unless and until someone is pushing the book, the book would not continue in state of motion. It would come to rest of a sudden. And from there, we have come to the point where we see that if you ignore friction, I mean, if you ignore these resistive things, the object tries to continue in its state of whatever it is. I guess, this is not wrong per se. The initial view was not wrong. The initial view is limited to certain conditions and it still held good for centuries. So this ability to look at things in an evolutionary manner, this ability to, you know, understand the influence of these views is what I understand or what I feel are quite important when we speak of philosophy of science.
It's been most interesting talking to you, Vinay. I'm sure everybody here is, going back much wiser and better informed than we were before we joined. And it's very, very heartening to know that, we're making every attempt to make a subject like science, like which like maths has sometimes scares people and they think it's some mysterious thing, but in fact it's part of our day-to-day lives. So thank you very, very much for being with us. Thank everybody here, and uh, wait for the next installment of LC Live, which will be the first Wednesday of the new year, January 2024. Until then, a very happy new year to everyone. Thank you, Vinay. Thank you.
Thank you very much. Thank you, all the viewers.